So we're going to start today with a warm-up, and so this is what your warm-up looks like. It's the first quadrant. So I'm going to give you about 3 minutes, and I want you to fill in the radian angles, the ordered pairs, and then on the outside of the ordered pairs, the tangent values, okay? So without looking at anything, this is just what can you get out of your little brain, okay? So if you're watching the video, then you're going to need to pause this to make that happen. I'm giving y'all 3 minutes. There we go, pi fours. Okay, so if you haven't done so already, then check yours against mine. Hopefully the purple and green should be kind of a no-brainer at this point. If you've actually been, trying to do the things along the way that I've been dragging you through. We talked about tangent just a little bit. We haven't done a whole lot with the tangent. We figured out what these values are. I don't remember if it was Thursday or Friday, but last week at some point. And so now you could figure them out every time, but you're not really going to have time for that. If you remember, I gave you that little sentence, you are one really overwhelming third wheel. Like the whole sentence, because you're not going to want to have to write all of them out every single time. But if you at least know what it is and you know that it starts with you, that's going to help you remember that this one's undefined and this one's 0, so you can keep those straight. Square root of 2 over 2 over the square root of 2 over 2 is 1, so that one's pretty easy. And then you've got these two, right? All these 3's. Remember, if you've got 2 3's in there, it goes with the 6 angle. 1 3 goes with the 3 angle, and then hopefully that's pretty easy for you to keep tied together, okay? Any questions at all about the first quadrant? Because again, if we get the first quadrant down, we can do all the rest. All right, so then let's get to the actual notes for today. That is the wrong thing. There we go. All right, so reference angles, they are not new. This is just kind of we don't even have to read what they're about because we know, right? We've seen this, we've done this. So let's just talk through these again because it's important for us to, first of all, recognize how easy the reference angles are when you are in radians with your special angles. Okay, if I was in degrees, I'd have to do some actual subtraction and addition and stuff. But with our special angles and radians, it's super easy. And then also the actual angle that we're getting it from, it's important that we know which quadrant we're in. So if we look at number 1, 2 pi thirds, what quadrant is that angle in? The second, very good, because this would be 3 pi thirds, then we back up, so it's in the second quadrant, it's right about there. So this is 2 pi thirds. Then my reference angle, always acute, always positive, always the shortest way back to the x-axis. Always super easy with my special angles. So what's the reference angle? Pi thirds, exactly. If this is 2 pi thirds, it's pi thirds. If it's a pi thirds angle, your reference angle is pi thirds. If it's some sort of pi sixth angle, your reference angle is pi sixths. Some sort of pi fourths, it's a pi fourths. It's that easy. So it's really more important that we're doing these so we know which quadrants we're in to begin with. So let's look at number 2. 11 pi sixths. What quadrant is that in? Fourth. Because this would get me to 12 pi sixths, and then I'd have to back up 1. So it's about right here. So this gives me 11 pi sixths, which means my reference angle is what? Super easy. Pi 6. The quadrant that you're in has nothing to do with the reference angle, really. I mean, your reference angle you can figure out before you even worry about the quadrant, but then the quadrant's going to be very important to us as well. Okay, negative 5 pi fourths. What quadrant is that in? Second. Okay, so it's negative, so I have to go clockwise. If I go to pi, that's 4 pi fourths, and then I have to go 1 more, so that's what puts me in the second quadrant. So this is negative 5 pi fourths. So my reference angle is what? Pi fourths, exactly. here, and it is pi fourths. Okay, I'm going to give you a few minutes, and I want you to do 4, 5, and 6. If you're watching the video, then pause this and then check yourself with me. All right, so if you haven't done so already, check yourself with me, see if we agree, and let me know if you have any questions at all about any of them. Are we good? So even if we're not drawing them, we need to be able to figure out what quadrant we're in and what the reference angle is, okay, without having to draw them every single time. Then we're going to use that information to help us figure out our trig values. Today we are still just talking about sine, cosine, and tangent. Tomorrow we're going to start talking about secant, cosecant, and cotangent. So it's super important that you get sine, cosine, and tangent down pat so that when we throw in the other ones, you're not getting all these numbers mixed up in your head. All right. So we are looking for the sine of 2 pi thirds. So here are the thought processes you want to go through. Today we're going to write them down as we think through them. In the future, if you don't actually write it all down, that's fine, but you're still going to have to think through the things. So first of all, what quadrant is 2 pi thirds in? Second. Okay, so I'm in the second quadrant. And then I have to decide, in the second quadrant, is sine positive or negative? And remember, we had that little saying that helped us. It was all what? Students take calculus. Yes. So that means that in the first quadrant, everything's positive. In the second quadrant, it's just sine and it's reciprocal. Third quadrant's tangent. Fourth quadrant's cosine. So if I'm on number 7 and I'm in the second quadrant, sine is positive. So that's good. So that means that the sine of 2 pi thirds is whatever the sine of pi thirds is. And that I should either know pretty quickly. Like if you don't like the hand trick or you have another way, that's fine as long as you actually know it and can figure these out. But so the sine of pi thirds is what? Square root of 3 over 2. So my answer is square root of 3 over 2. That's why the quadrant's important. The quadrant's important because it tells you if your answer is positive or negative, and then the reference angle is where you get the actual value from. So cosine of 5 pi fourths. So what quadrant is 5 pi fourths in? Third. Okay, so we're in the third quadrant. And in the third quadrant, is cosine positive or negative? Negative. Okay. So then we know that our answer is a negative something. My reference angle is just pi fourths, and the cosine of pi fourths is the square root of 2 over 2. So my overall answer is negative square root of 2 over 2. Okay, any questions at this point? All right. So then I have tangent of 11 pi sixths. So the first thing I want to think is what quadrant is 11 pi sixths in? Fourth. So I'm in the fourth quadrant, and then I know in the fourth quadrant tangent is negative, right? So my tangent values, which might not be as solid in my brain as the rest of them, I have a 6, it's a 6 angle, right? Which means it's the square root of 3 over 3. I got 2 3's in it, and then it's negative because I'm in quadrant 4, and that is my overall answer. Negative square root of 3 over 3. We good? All right. So let's look at number 10. Negative 2 pi thirds. What quadrant is that in? Third. Very good. So I'm in quadrant 3, and in quadrant 3, sine is negative. So then I use my pi thirds angle. Sine of pi thirds is square root of 3 over 2, but it's got to be negative, so I get negative square root of 3 over 2. There's like 3 little steps you got to think through, but the more you do it, the quicker that thought process goes. Any questions at all? Okay. All right, so now we're going to talk about the quadrantal angles. And I wish I'd given you a little bit more space down here, and I didn't, but we're going to make this work, and it'll be fine. Let's see. So if I'm at 0 or 2 pi or any of the multiples of that, then I know that my ordered pair is 1, 0, right? If I am at pi halves, or any multiple that gets me there, then my ordered pair is 0, 1. If I am at pi, or any multiple that gets me there, this is negative 1, 0. And then when I'm at 3 pi halves, I'm at 0, negative 1. Okay, so let's see what information that we can gain from this. Because of these ordered pairs, because again, these seem to be the ones that are the most difficult for some people. I know you know the difference between X and Y, but it's like I ask you a question and then your brain just becomes scrambled eggs and you can't get anything out of it. I don't really know what happens. But so from here, if I'm talking about 0, again, or 2 pi or whatever, and I want the sine of 0, what is the sine of 0? 0. It's the y value of that ordered pair. It's 0. And then the cosine of 0 is what? 1. Then what is the tangent of 0? 0. Because I put 0 over 1, right? My ordered pairs are always cosine theta, sine theta. We have written that at least once, probably more than once, every single day for almost a week. And so hopefully you got that nailed down now. And again, if we keep doing the same thing, repeating ourselves and writing the same things over and over again, do you think it's important? Yes, we're practicing. Okay, so then when I look at pi halves, the sine of pi halves is what? 1. Don't overthink it. It is the y value. It is 1. The cosine of pi halves is what? 0. The tangent of pi halves is undefined. Very good. So again, that whole sentence, oh gosh, I can't even, hang on, I can't write and talk at the same time apparently. Undefined. You are one really overwhelming third wheel. Just the you start at the top. It's got to be undefined, right? Okay, so then let's look at pi. The sine of pi is 0. The cosine of pi is negative 1. And the tangent of pi is, it's 0. Because I'm put y over x at 0. So at 0 and at pi on both ends of the x-axis here, the tangents, it's 0 and 0. Okay, for both of them. Alrighty, then we've got the sine of 3 pi halves. What is that? Negative 1. And then the cosine of 3 pi halves is 0. It's the x value. Tangent of 3 pi halves is undefined. Because negative 1 over 0 is undefined. So same thing like on the y-axis, both of those values for tangent are undefined. Okay. Those I don't really consider, like even for me, I don't have those memorized. I think about where I am on the circle and then I can give you the answer. I don't really have any of these memorized because, again, my brain doesn't work that way. I don't have the capacity for all of that. Plus, if I memorize it, I might know it now. But a year from now, if I got to pull it out of my brain, who knows what's going to come out. But if I can think my way around the circle, I can tell you where I am and what the values are. All right, any questions at all? We all good so far? Awesome. All right, so let's look at the next page. Sorry about you having to cram all that in there. Okay, so unit circle, we've talked about a lot. We've written this at least once every single day, I think. Sine of theta is y. Cosine of theta is x. Tangent of theta is y over x. Our cosecant, which again, we'll start looking at the actual values tomorrow, but we should know that cosecant is the reciprocal of sine, so it's 1 over y. Secant, reciprocal of cosine, so it's 1 over x. Cotangent, reciprocal of tangent, so it's x over y. And our coordinates can be written as cosine theta, sine theta. Hopefully that is not new information for you. Then the unit circle can also be considered the 16-point unit circle because it's got those 16 important points on there. So it's used to map these angles to special values. That would be our pi sixths, pi fourths, and pi thirds, as well as 0, pi halves, pi, 3 pi halves, and 2 pi, which are your quadrantals. Okay, so then we're going to go through some more values together, and then you're going to do some on your own. But these are not, hey, let's look at a circle and pull off the answer, or look at a question we already did that has the same answer. These should all be coming out of your little brain to help you figure this stuff out. So I'll write down again, all students take calculus. And we're really going through these the same way we did the ones on the front. So I'm going to start with the 3 pi fourths. What quadrant is 3 pi fourths in? Second. And in the second quadrant, sine is positive. My reference angle is pi fourths, so that's the sine of pi fourths is whatever my answer is, square root of 2 over 2. Okay, everybody okay with that process? Yes? Again, just practicing. I know it seems like the same thing over and over again, but that's what practice is, really. All right, so cosine of pi. What quadrant is that in? It's not, right? It's a quadrantal. So it's a quadrantal angle, which means I'm not looking at the quadrant for the sine. I just have to think about where I am with pi. And the cosine of pi is what? -1. Okay, you should picture yourself, where are you on the circle and you want that x value. That's where you're getting that one from. Okay. All righty. Tangent of -5 pi thirds. What quadrant is that on? I'm sorry. 1, right? Very good, because we're going negative, so this is in quadrant 1. Everything's positive in quadrant 1, so we're good. So we just need tangent of pi thirds. Okay, so tangent, we have a 3 in the denominator, which means our answer is just square root of 3. You don't have to actually do any work. I mean, you can figure it out with work, but we want to get past that and just know how they relate. Okay, sine of 2 pi thirds. What quadrant's that in? 2. We're in quadrant 2. And in quadrant 2, sine is still positive, right? So then the sine of pi thirds is square root of 3 over 2. Then tangent of 3 pi halves. 3 pi halves is in which quadrant? It's not. It's a quadrantal. Good. And then what is the tangent of 3 pi halves? Undefined. Very good, because it's on the y-axis there. It is undefined. Okay, last one we're going to do together. Cosine of -5 pi sixths. What quadrant is that in? Third, because -6 pi sixths would get me all the way to pi, so I'm in the third quadrant. And in the third quadrant, cosine is negative. And then the cosine of pi 6 is the square root of 3 over 2. So my answer is negative square root of 3 over 2. Okay. Any questions about any of those? All right, so I'm going to give you about 5 minutes or so to do the last 6 on your own. Let me know if you have any questions. If you're watching the video, then you need to pause, because I'm not going to just sit here and let the video run for 5 minutes. So pause, do them, and then check yourself. Okay, I hope I gave you all enough time. Go ahead and check yourself with me. If we agree, and if you have any questions at all, please let me know. You think it's getting a little bit easier to think through this stuff? You can think through it a little quicker. Yeah, that's why we keep practicing. So let me remind you about your tournament, which was your assignment from Friday. In the tournament, it ends tomorrow night at 11. I couldn't choose 11:59, so it ends tomorrow night at 11. You can go through and play those games as much as you want, and it keeps your best score. I think they're good games because they're kind of random, but remember, you can't play them on campus because our Wi-Fi likes to block that stuff. Your assignment today it is in Delta Math, and it has some timed portions to it, but don't let that freak you out because it's really kind of tons of time. I'm going to start scaling back that time a little bit. But somebody asked me last period, how do I get it to keep my score? Because once I get my 10 right, I get one wrong to stop it, but then it doesn't count it. That's not the way you stop it. That's why it's not counting the score. So once you get your 10 right, it'll let you go for hours, and you can do millions of questions if you want. So it actually stops your, like the time keeps running, but it records the time when you get your 10 right or whatever it says. And then you have to, if you hit stop, don't get one wrong to make it stop because it won't record your answer then. But do that, and I think that's it. Any of y'all have any questions for me? Okay, so keep practicing. It's going to get better and better. And go ahead and get your discussion question done, and you can get started on some homework.